In the name of Almighty Allah, most gracious, most merciful. Assalamu alaikum, dear students. I'm Tahir Irfan, A-level chemistry teacher at Roots International School and College, Sialkot. Today we are going to understand the chemical behavior of benzene, that is a fundamental concept in organic chemistry for A2 level. Okay, first of all we need to understand the benzene ring. As you can see, I have drawn a structural formula over here that shows benzene. We can see there are 6 carbon atoms and 6 hydrogen atoms. The molecular formula will be C6 and H6. As we can see, all these 6 carbon atoms, they are connected to each other in a specific 6-corner shape, that is hexagon, and we can also see there is an alternation of single and double bond. Single, single and double bond. We can also see each carbon is making 4 covalent bonds, one with hydrogen, one with the adjacent carbon atom, and double bond with the next carbon atom. So we can simply write this structure formula in this way as well, where we are showing the alternative single and double covalent bond. We are showing the edges where there are carbon atoms, and as we know, in skeleton formula we do not write the name of carbon or hydrogen atoms. Okay, very important. In many books we find the benzene written like that. There is a 6-corner shape with a circle in between. So basically the purpose of putting circle is very important. As you can see here, there is an alternation of single and double covalent bonds. But very important point is this: the location of double covalent bond in benzene is not fixed. It is possible this double covalent bond can shift towards this region. In the same way, this double bond can shift towards that region, and this can shift here. There is equal chance, there is equal probability, or you can say these double covalent bonds are continuously shifting. In nanoseconds they are continuously shifting. That is why in most of the books the formula for benzene is written like that. They put a circle around that. It means alternation of single and double covalent bond. Please remember, this circle doesn't mean that all carbon are making double covalent bond. This circle means there is an alternation of single and double covalent bond. This is more clear from this picture. As you can see, when carbon is making double covalent bond, we have studied in our AS level, each carbon is sp2 hybridized. sp2 hybridized. It means each carbon is making 3 sigma bonds and one 2p orbital is available for making the double covalent bond. We can see that each carbon in benzene ring has an unhybridized 2p orbital electron available for the double covalent bond. So there is a total of 6 electrons in 2p orbital available for double covalent bond. So there is equal chance that these two 2p electron make double covalent bond, that is the pi bond, and these two they can make, and these two. But there is same probability that the double covalent bond is formed between these two, or here or here. So it means we cannot uh, predict with certainty that double bond lies here or there. So that's why we put a circle around that. As you can see in this 3D diagram, there is a circle that represent the actual structure of benzene molecule. Benzene is very important chemical because this is the basis for aromatic organic compounds. This is more evident from this one. Organic hydrocarbons containing one or more benzene rings are called arenes. So please remember this one. You will find this in your syllabus. Arenes. It is possible some organic molecule have one ring for benzene, and it is possible some have 2, 3, or even more than that. But if you find benzene rings and hydrocarbons, means they only contain carbon and hydrogen, so we call them arenes. In general, compounds of benzene are known as aryl compounds or aromatic compound. Traditionally, we used to say aromatic compounds. So, all those compounds which are derived from benzene ring, it is possible some other atom may join here, like oxygen may appear, chlorine may appear, bromine may appear, sulfur may appear. So, for example, it is written, an example is chlorobenzene. As the name is telling us, a chlorine atom is going to be added to benzene. For example, if one hydrogen, suppose this one, is replaced by a chlorine atom, so that particular benzene will be called as chlorobenzene now, because it has replaced one hydrogen with chlorine. So it is also possible. So other than chlorine, there are other possibilities like nitrogen, sulfur, or many other. As you study the syllabus of aromatic organic chemistry for A2 level, you will find many different derivatives made from benzene ring. One more very important concept, overlap of p orbitals. As you can see here, p orbitals, overlap of p orbitals produces a ring of delocalized electron. Very important. We have heard this word delocalized electron in the case of metals. We know metals contains delocalized electrons, and that is the reason why metals are conductor for heat and electricity. But these delocalized electrons, as we see in benzene ring, they are not the same as we find in metals. Electricity cannot be conducted in benzene. These delocalized electrons cannot leave their place. They are confined to these rings. Okay, so please remember, we use the word delocalized electron just to understand the bonding inside benzene ring. These delocalized electrons are not available for electricity conduction. So overlap of p orbital producing a ring of delocalized electron above and below the plane of benzene carbon. Above and below, we have studied in AS chemistry that the p orbital, they are dumbbell like shape and they have electronic density above and below the main axis.